we're covering today is called the Binomial Theorem. Okay? This is really kind of a cool problem. Suppose I want to compute x plus 1 to the third power. Okay? The reason it's called the binomial theorem is because it's used for what? Binomials. That's a binomial. And I want to compute it to the third power. X plus 1 cubed. Alright? Any idea what the first term is? It's x cubed. Any idea what the second term is? If you say 1, I'm going to be angry. Right? I'm going to say plus here. But what the binomial theorem helps me with is filling in the gaps. What comes next? I know it's going to be x cubed. I know the next term is not 1. Why do I know that? Because I understand things like this. X plus 1 squared. Do you guys have memorized what that one is? X squared plus 2x plus 1. And again, because it's x plus 1 times x plus 1. Right? So if I want to figure out what x plus 1 cubed is, all I have to do, I guess, is work out what? X plus 1 times x plus 1 squared. Right? And that's x plus 1 times, you guys told me, x squared plus 2x plus 1. With me so far? Now what do? Distribute the x. So this equals x cubed plus 2x squared plus x. But then I also have another, I have to distribute the 1. So plus x squared plus 2x plus 1. And so the final answer here is x cubed plus, what would come next? 3x squared plus 3x plus 1. Okay? And that's one I actually have memorized. But I didn't know if you would. Okay? Now, I still haven't used any theorem. A theorem is something that mathematically we have proven is true. And it gives us a formula to compute x plus 1 to any power. Okay? So, for example, I could ask you guys, what is x plus 1 to the 5th power? Could you do it? How much time do you need? More than we have, right? So let me do it instead. It's x to the 5th plus 5x to the 4th plus 10x to the 3rd plus 10x squared plus 5x plus 1. How? Well, the binomial theorem. Let me show you how. And it all comes down to recognizing patterns. Okay? Now, let me write down right here x plus 1 to the 3rd power. Okay? And I'm going to do some highlighting. I want to point out that this was a 2 and this is a 1. And I'm going to point out that there's a 1 in front of the x squared there. And so when I do x plus 1 to the 3rd power, I'm going to point out that this is a 1, and this is a 3, and this is a 3, and this is a 1. Those are the coefficients that I want. 1x cubed plus 3x squared plus 3x plus 1. That's what it is. I'm going to go up and I'm going to write, what's x plus 1 to the first power? Well, that's obvious. What is that? It's x plus 1. But I think you know what I'm going to do here. I'm going to write 1x plus 1. Has anyone ever seen these numbers in pink? Emily has. Barb has. Augusto has. For those of you that haven't, let's make another one. X plus 1 to the 0 power is 1. Okay? X plus 1 to the 4th power is what I'm going to do next. But what I'm going to point out is these numbers in pink, maybe if I write them over on the side, you'll recognize what's going on. They form a triangle. Do you guys see that? Sometimes called Pascal's triangle. Pascal was a mathematician and philosopher from France from about 400 years ago. Blaise Pascal. And this triangle's not his. He worked with it, but people have known about it for thousands of years. You can find this in ancient Babylonian texts, this exact triangle. They were bewildered by it, mystified by it. What's the next row of the triangle? Do you guys know the pattern? 1, 4 is correct. This one number here is going to be a 6. This is going to be a 4, and this is going to be a 1. The pattern is this. To get a number, I can look directly above and add those two. See how 1 plus 2 is 3? 1 plus 3 is 4? So now to get the next row, what am I going to have? 1, 5, 10, 10, 5, 1. And notice that those are exactly the coefficients I needed to get x plus 1 to the 5th power. So I guess to continue here, x plus 1 to the 4th would be x to the 4th plus 4x squared plus 4x to the 3rd. You just have to keep moving the coefficient, the powers down, plus 6x squared plus 4x plus 1. But I'll tell you what, this is a huge, huge time saver. And I always like college algebra students to walk away, whether or not you know all the theory in this section, it's just nice to know it as a time saver. Take the problem we had to do last time when I said I wanted you to do, I think it was 1 plus the square root of 5 over 2, right? And I wanted to raise it to the 3rd power. I'm going to show you guys that one, how I would do that using the binomial theorem. Okay? So 1 plus the square root of 5 over 2. To the 3rd power. Well, this is going to be 1 plus the square root of 5 to the 3rd power over 2 to the 3rd power. So it's something over 8. All right? Now, what I like to do, when I'm first learning this anyways, is I like to kind of replace things. Let's call this x plus y to the 3rd power. Okay? And so you have to know what row of Pascal's triangle you're in. Otherwise, this doesn't go anywhere. Okay? So again, Pascal's triangle looks like this. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Which row do I want to use? I'm going to use the 3rd row. One nice thing is that whatever power you're raising to, that's always going to be the 2nd number of the row. Okay? So if I have x plus y to the third power, now I know how to rewrite that. How can I rewrite it? Well, it would be using these coefficients. See that? So what's the first term I'm going to write? 1x to the third power. Okay. Oh, this is a little tricky. What's the next term I'm going to write? Well, I'm going to write plus 3x squared, but now I need to multiply by y. And if you don't see that yet, I'm not totally surprised, because there's something I didn't explain. I did my example with x plus 1. It would have been smarter to do x plus y. Here, let me show you. I'll do it down here. If I had x plus y times x plus y quantity squared, that would be x plus y times what? You could do the orange one. What would that be? X squared plus 2xy, because that's what I get from the outer and inner terms, plus y squared. When I multiply through by x, what's the first thing we get? X cubed. What's the next thing we get? 2x squared y. What's the next thing we get? xy squared. What's the next thing we get when we distribute the y? Well, we get y times what? X squared. But you know how I want to write it? I want to write it alphabetical. I'm going to write it as x squared y, and so I'll line it up here so I can really see that it's going to be combined. What's the next thing we're going to get? When we do y times 2xy, what are we going to get? 2xy squared, and then the last thing we're going to get is y cubed. So you could see what we're going to get. We really are going to get x cubed plus 3x squared y plus 3xy squared plus y cubed. But again, this is the long way. The short way is, if I know the binomial theorem and I understand the pattern, I can read the coefficients directly from Pascal's triangle. So this is going to be plus 3xy squared. Notice the powers of x keep going down, and what also happens is the powers of y keep doing what? Going up. What's the last thing going to be? 1y cubed, right? Over 8. And now to finish the problem, I have to replace all the x's with what? Well, those x's are actually 1's, and the y's are actually what? Square root of 5. So I have to put those things back in. So I'm going to get 1 cubed plus 3 times 1 squared times square root of 5 plus 3 times 1 times square root of 5 squared plus square root of 5 cubed over 8. And if I work this out, I get something over 8. 1 plus 3 square root of 5 plus, well, the next part is 3 times 5. And the next part is 5 square root of 5, if you work it out. And sure enough, that's 15 plus 1 is 16. 3 square root of 5 and 5 square root of 5 is 8 square root of 5 over 8. Yeah, we can, right? We can write it as 16 over 8 plus 8 square root of 5 over 8. And so it's just 2 plus the square root of 5. And the other one was 2 minus the square root of 5. And so when we added them together, we got 4. So some of you are going to tell me, you know what? That actually took longer. And you're probably right. You're probably right. But imagine this problem. Find the third term in the expansion of x plus 3 to the 7th power. Right? By the way, computers nowadays can spit that out, and I can just read what the third term is. Okay? This is where the binomial theorem really helps. The binomial theorem. So, what do I need? Well, I need more rows of the triangle, right? What row do I want to go down to? All the way down to where the 7 is, right? So this would be 1, 5, 10, 10, 5, 1, 1, 6, 15, 20. You guys, there's a problem, is that the numbers are getting really big. Luckily, this says 7. If it said 17, I wouldn't be so happy anymore, right? What is the third term coefficient going to be? The coefficient will be, well, I claim the coefficient will be 21. How do I know that? Because the 7th row is 1, 7, 21. You guys see that? Okay. But to understand this, you need one more thing. You need to know what these numbers are. So, what I would say is, the number we seek is denoted 7 choose 3. Choose 3. And they give you a formula for it in the book with the factorials. I don't have the time for that today. But I do have the time to show you how to get it on the calculator, which is a nice tool to know about. So I'm going to go ahead to my calculator here, and I'm going to type in 7. And I'm going to go to my math menu. And the way I go to my math menu, right under my alpha key, I have a math button. And to find the choosing numbers that are in this theorem, I go all the way to the right. There's a math menu, a number menu, a complex menu. Do you know what this PRB stands for? Probability. And if you ever take probability or statistics, I guarantee these numbers are coming back. NCR, that means N choose R. So I'm going to press that. This means 7 choose 3. Oh, I screwed up. How did I screw up? Oh, because the third term is 7 choose 2. Sorry about that. There's 21. Why do I need 7 choose 2? Because in Pascal's triangle, when you have this row, is the row we were looking at. Those numbers are 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3, 7 choose 4. There'd be a couple of 35s here. And then 21 would be 7 choose 5, 7 would be 7 choose 6, and the last one is 7 choose 7.